Good morning everyone, and welcome back to our tutorial on the TNC Techniques Manual. Today, I'll write something on our piece. As some of you requested, the manual has a function for making small writings with a milling cutter, either spherical or pointed. I've selected a milling cutter and a rough piece with a diameter and length of 100. In my career, I've never used this function, so we'll improvise a bit today. Not knowing a function shouldn't stop you from trying it. We have a graphic to help understand mistakes, so go for it. It might take longer the first time, and your supervisor might notice, but practice makes perfect. I've set up a candle-shaped milling cutter with a point to write hello on the cylindrical part of our piece. Call the milling function, go to special, and select the function for letters. Set a safety distance for the milling cutter, and adjust radial and axial feed. This is manageable. Just focus on the feed for writing and depth. I have to say that in my working life, I've never used this function. So today, I took a look at it, but we'll improvise a bit because I haven't prepared anything particularly targeted. I didn't want to do that because it should be clear to you that not knowing a function doesn't mean you shouldn't try to use it. I remind you that in this area, we have a very interesting graphic that helps us understand our mistakes. So, even if you don't know something, go for it. Maybe the first time it will take you a bit longer and your supervisor will look at you sideways. Or the second time you'll leave some sparks. And I hope your supervisor will say, thank you, because there are those who are good at it and those who are not. So, I've already set up a candle-shaped milling cutter with a point, and I want to start writing hello along the side of our piece, so on the cylindrical part. All we need to do is call the milling function, so the cycle, and go to special. You can see right away that it's the function for letters. Select the function, and you need to initially set a safety distance for the milling cutter before starting to work on the piece, as well as a radial and axial feed. This is not a problem. The feed with which you will write, and the feed with which you will go into depth.
Writing and then selecting the plane, you have XC and ZC. Obviously, ZC will allow you to write along the cylindrical part along the side of your piece. CX, on the other hand, is in front. Let's start with ZC and begin writing the data related to our position. H is the first axis, Z minus 10. Let's set it to minus 30. What does minus 10 mean? It's the Z coordinate where your text will start. V corresponds to B, and B usually relates to writing along the spherical part. Sorry, cutting condition. Okay? V corresponds to the diameter you want to write on, and B is the base position, which also corresponds to the diameter. Be careful, not the diameter. You need to indicate a radius. Remember, our piece has a diameter of 100, so I'm going to write 50 and 50 would be the basic position. Car depth is the depth of the engraving. Size is height of the character expressed in millimeters. 0, 90, 180, 270. That is how you want to write the text. We'll try all four so you can see. You see here it's 180, which is already good. 180, let's go back to see it, because it will write from left to right. Not everything is customizable. For example, if I wanted to flip the text, I can't do that. If anyone knows how to do it, please share, because some things are unknown to me as well. I had written magnesium. Let's write hello instead. We insert it and you see it. Writes a cycle. Already here you understand that I can change hello without even entering the figure modification. Let's simulate. Simulate, restart, and start. There you go. You see it's wrong because I selected the wrong milling cutter. I apologize, it was 41. 41 is the correct cutter. Let's go back to simulate, restart, start, and there we have written hello. Let's change some parameters to learn how to understand them. So let's go to our cycle, because it's not working. I miss the real CNCs. Let's modify this 1. But let's not touch anything, because it always works fine. What can we modify? The string is fine, that's not a problem. But we can modify it. For example, we're currently at 180 degrees. Let's try writing and see what happens if we set it to 0 degrees. Modify. Simulate. Restart, start, and you can see that it always starts from the same point. Before, it was going towards the self-centering. Now it's going towards the tailstock. It's the same way to achieve writing, either along the diameter in one direction or the other. So we've tried 0 and 180. Now let's write 270. Modify it, simulate, restart, and start. And you can see that now the self-centering rotates to right parallel to the spindle. Of course, you can also reverse the text. Let's go back to modify. As you can see, we've tried everything. I won't show you that one, but if we set it to 90, it writes in reverse. Z minus 30. Let's try to understand it. Let's write just Z. I say H because I know that. Z minus 5. Enter, modify, and you'll see that now we are much closer to the head of the workpiece. You see, it even indicates the 0 point well here. So, having taken a character of 8.3 mm for the text, I'm actually outside the piece. My naivety, but it's logical, it should be like this. Let's modify it, let's change this, and let's write it like this. So my Z minus 5 is fine. Send modify, and you'll see that now we are much closer to the head of the workpiece. You see, it even indicates the 0 point well here. So, having taken a character of 8.3 mm for the text, I'm actually outside the piece. My naivety, but it's logical. It should be like this. Let's modify it. Let's change this, and let's write it like this. So my Z minus 5 is fine. The depth is 0.5 if I want a piece that's particularly deep, a particularly deep engraving, but with text, it doesn't really make sense. So let's do the opposite. Let's go deep just to actually show you that we have a text where we would have broken the cutter, particularly deep. So you see, it's all very, very intuitive indeed. Let's go back to Z5. Size is the character height. Let's set it to 18. And you see that we have a nice big character. The ones we can't get wrong are these. So you see we have a piece with a diameter of 100. Well, V and B, when writing along the diameter, must always match exactly the radius we want to write on. It's very simple. If you write 60 here, modify, simulate, restart, you see that you're writing in the air because it gave you a base point higher than the diameter, and so the machine gets misaligned. That's the same data entry table for writing frontally, and it asks for both, so it's not good to have different V and B values. We can also go back using the undo button, if I'm not mistaken. I think it confirms, and you see we have V and B back to 50. Now, regarding V and B, they simply need to match the radius of the area where we want to write. Now let's write something on the head. So let's go back with my cutter, direct alter, and delete it. Let's modify our cycle. Let's change it so we no longer choose ZC but X. Modify, simulate, restart, and you see that you're writing in the air because it gave you a base point higher than the diameter, and so the machine gets misaligned. That's the same data entry table for writing frontally, and it asks for both. So it's not good to have different V and B values. We can also go back using the undo button if I'm not mistaken. I think it confirms. And you see we have V and B back to 50. Now regarding V and B, they simply need to match the radius of the area where we want to write. Now let's write something on the head. So let's go back with my cutter, direct alter, and delete it. Let's modify our cycle. Let's change it so we no longer choose ZC but X. And I start, simulate. And so as far as V and B are concerned, they simply need to match the radius of the area where we want to write. Now let's write something on the head. So let's go back with my cutter, direct alter, and delete it. Let's modify our cycle. Let's change it so we no longer choose ZC but X. C, which means we're at the head. Here the positions become a bit more difficult to interpret. Let's start by setting H0. V, the diameter at which we want to make our writing. Let's try to simply put 25. B is the base point, right on the outer face, for a stepped piece. Set depth and height to 8, angle to 0. Start. H0 shows an angle. It started writing. Change view. X and C axis. Center writing. Modify H to -15 for centering on C axis. It's more centered, slightly below C axis. In this particular case, we begin by setting the angle to 0 degrees, and then we proceed to observe what transpires as a result of this adjustment. We simulate a restart, and then we initiate the process once more. Perfect. This demonstrates that there is indeed an angle present when we configure H0. You can clearly observe that it commenced writing, precisely as expected. However, C is not considered an angle when operating within the parameters of C and Z. Let's adjust our perspective so I can provide a clearer explanation. Now focusing on the X and Z axis. There we go. Perfect. We have the X-axis oriented in this manner, and the C-axis is positioned accordingly. You can see that H0 corresponds directly to C0, and V25 is equivalent to a diameter of 50 units. I have a desire to center this writing more accurately. Theoretically, I should have a conceptual understanding of its length. Therefore, if I proceed to modify H and adjust it to -15, it will achieve a more centered alignment relative to the C-axis. Let's make this modification, simulate a restart, and initiate the process again. You can observe that it has become slightly more centered, perhaps even excessively so, as it has shifted below the C-axis. Consequently, H can also be adjusted from this point onward. And there's no need to dive in. And this applies to all the other macros as well. Once you understand it, you can modify them without going in. Simulate. Restart. Start. And you'll see it starts to be more centered. Now let's look at something else. So about the degrees, that is, the position discussion is neither more nor less than what we had before. We wrote at 0 degrees. I don't know if you noticed that when it simulates, it writes like this and then moves the spindle. But if we want to write it top down or bottom up, we just need to change the degrees. Everything else remains unchanged. Of course, if we have a figure with more panels, if we set Z to 10, it will write at Z10, so B corresponds to Z. Now, what is my limit? My limit with this writing method is that I can't do it, because I don't have any parameters to do it. My hello in a circular way. So let's simulate. You see it writes at 0 degrees and then moves. I would like to write my hello in an arc relative to the diameter where I'm going to write it. We have one and only one solution, which is this, and it requires a bit of cleverness from the lathe operator. Let's modify the position, starting from Z at 0. Okay, let's write just the C and modify it. Let's see what happens. Simulate, restart, start. We've written only and exclusively the C. Good. Now let's copy this string. Before copying it, let's move the origin of my C axis. How do we move it? I already explained it to you. G52C 15. So, I wrote minus because I've already done my tests. The first time I did it, I guarantee you I wrote plus 15. But now, let's see. Insert, then go and select this string, which you bring it under my G52, C15, and go into the parentheses. Then you bring it down with the Inctors button and write I, alter to see what happens. Simulate a restart, start. It's tedious, but it's the only solution if the client asks you to write along a certain arc. So the same thing applies. You select G52, copy it, select both strings, and paste it once, then paste it again. Now we're going to transform C15 into C30 and this into C45. This becomes an A and this becomes an I. Hi. Now you'll understand that you need to move the 30 and the 45 down by 5 degrees because the I takes up less space. I hadn't thought of that, but the graphics help us find the best solutions. A little exercise I'll leave you to do at home could be to write a number, and using the parametric instructions I taught you in previous tutorials regarding ISO programming, turn the C into a 1, but don't call it 1, call it with a parameter, and that parameter should increase each time. It worked on my CNC. I don't know if it works on this simulator, but you could engrave a number that increases each time you make a piece. This could be a fun and interesting exercise. I guarantee I've never used writing in the company, but someone asked me for it, and indeed now there are some requests to engrave pieces if you don't have a micropoint machine. Doing it on the machine can be useful for sampling. This becomes a and this becomes an I. Hi. Now you'll understand that you need to move the 30 and the 45 down by 5 degrees because the I takes up less space. I hadn't thought of that, but the graphics help us find the best solutions. A little exercise I'll leave you to do at home could be to write a number, and using the parametric instructions I taught you in previous tutorials regarding ISO programming, turn the C into a 1, but don't call it 1, call it with a parameter, and that parameter should increase each time. It worked on my CNC. I don't know if it works on this simulator, but you could engrave a number that increases each time you make a piece. This could be a fun and interesting exercise. I guarantee I've never used writing in the company, but someone asked me for it, and indeed now there are some requests to engrave pieces if you don't have a micropoint machine. Doing it on the machine can be useful, at least for sampling. So we get equipped and buy the micropoints. We've also seen this aspect. If you want to help me and ask me some questions, please don't ask me to make specific programs. I can't do that because it wouldn't be appropriate. But I will try to address some questions as we go along. Now, if God willing, the lockdown is over, so my presence on the internet will be a bit less frequent because I also have to work now. However, I will try to keep this channel updated with what I've done, which is quite a bit, and what we might do. Let's also see if we can tackle some differences between CNC and CNC. I thank you, and I hope you found this tutorial interesting. If you liked it, as always, give it a like and subscribe to the channel. Share it on your social media. If you didn't like it, just pretend you didn't see it. Thank you, and See you next time. Have a good evening.